Today we are going to be looking at electricity and making an electric circuit, and then going to test some items and see if they are conductors or insulators. So what you need is a 9-volt battery works best. We have some different ones here to test some different batteries, see how they work. We need some different household items that you can find around your house. You're gonna need some Scotch tape. And then we're using a strand of Christmas tree bulbs that we've gone and we've taken. So this one still has the rubber on it, but I've taken the rest of them and stripped some of the rubber off so that you have some of the wire exposed. So you also need some aluminum foil, some scissors. We've got some drawing paper to draw out our circuits first, and then we're gonna use the cardboard as our work surface. So let's get started, guys. Using what you know about a circuit, and Kaden, you're really the expert here.
Yeah.
What does a circuit need to be? What shape does it need to be?
A circle.
A circle, like circuit, circle. All right, so let's draw out some circuits and I'll tell you the pieces. You need your energy source. So you're gonna have your energy source.
Can I trace it?
Sure, you can trace it. And then we have we're turning our electric energy into, what did you say, Malia? What kind of energy? Light energy. And then we need the circuit that we're going to draw, how we're going to attach the light to the energy source. So we're going to draw them out first. First thing we're doing is just taking little strips of...
It actually works. Mom showed us with that one. It actually works.
We'll show it with yours. We'll see if you can get yours to work. So we're just folding them over into thin little strips so that we can use these as our wires for our circuit. So here we are building our circuits with the folded up pieces of aluminum foil and just our Scotch tape. On figuring out whether their circuit will work. Tape his bulb on, and if we can, you just put the tape right over the metal, the copper wires, and ideally you can get your bulb to stand up.
It's working. It's standing.
Good.
Can I see if mine works?
Yeah. So test it. He's got a circuit. That's all.
That is a myth. How? That is a myth. How? That is a myth. How? Dude.
How does that work? Why is it working like that?
I don't know.
You know, you studied circuits. What's happening?
Electricity is flowing through wires and going.
Yeah, connecting.
Wait, what? Oh, so it actually has to be placed on both torque. It can't just be like...
That's right. It has to be on both sides. Yep. It's got to be a continuous circle.
What if it's like actually a circle and that's closed off? So it's just like actually...
You could try that. Try to put a piece there.
Yeah.
I think that the tape at the end needs to be removed. So we'll try it again. Battery. And it's working.
It's just not that well.
Right. So the 9-volt battery, why do you think it works better?
Wait, how many volts is this?
I don't know. But let's just, so this is a 1.5 volt. It says
because 9 volt has more energy going into it.
Yeah.
So like.
Good. So what about this one? You want to try the AA battery?
Mom, I know one here.
It's about the same, isn't it?
I think it works
about the same.
little better than the default.
Than the size D?
Yeah.
It's still not as bright as the 9-volt.
No, the 9-volt is just like a 9-volt. Compare that.
Well, you know what? This one says it's a 1.5 volt, so that makes sense that these two would compare in energy.
That compared to like that.
Yep. Let's see if we've got yours working. Oh no. So it's still not working. So what do we need to do? Let's test a different bulb. Show everybody the mistake we found. So what we found is when she taped it down, we had a tape barrier in between the metal. The metal has to make sure it's touching. So let's check all your corners and get metal touching metal. Only with tape on.
I added another light. And look, it works.
Awesome. Now you've got 2 lights lighting up.
I'm gonna put like 2 there.
Okay.
stick one there. Oh wait, no, but then they
See
won't
how many
connect there.
lights a...
They have to go in parallel. Or
Try
else
it.
won't
You can
connect.
try it. Try a different type
But
of
if I
circuit.
put them there, then it won't connect. Unless I just add them on like that.
There you go. Try it. We've fixed it all up. There's no tape between the metal, right?
Yeah.
All right, let's try it. Oh no! This one's gonna work. It's not working! Oh my goodness, this one's giving us a hard 526. Yeah! 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 Finally! So, what did we learn that we can't? When is tape a conductor or an insulator?
Insulator.
So, what happens when you put tape between the metal? Does it?
It stops the wire.
Yeah, it stops the electric current from flowing. So we definitely want to make sure we don't have tape between our wires or between our wires and where our lights connect. Only tape on top. Now has 3 bulbs on a parallel circuit and they all work. Awesome!
I'm amazing.
Let's check it out. 3 lights, red, yellow, and blue.
I have 4.
Good job. You think you want to try a 4th?
Yeah, I'm putting on my
4 lights work. Show me with your battery. Yeah, nice. 5. I noticed that they're not quite as bright as it was when there was just 1.
Yeah.
Because they're sharing that. Now that you guys have built a successful circuit and you've got some lights on there, now we need to test some items to see if they are going to make a good switch. So we're going to test some of these items that are in here to see if they are conductors or insulators. You're going to make predictions. So you have a sheet here. Each of you can do at least 10. You can do more if you want. The first column, you're going to write the item that you are using. And then your second column is a prediction. You're gonna put either a C or an I. If you think it's a conductor, put a C. If you think it's an insulator, put an I. And then we're gonna test it out on your circuit. So we're gonna break your circuit somewhere and make a little opening. And then we're gonna put our object there and see if it will conduct the electric current or if it will insulate it, okay? And then we'll put our results here by putting an I or a C, okay? So let's test them out.
Mom, what is this?
I'm feeling
A cork, C-O-R-K.
totally feeling it right now.
Find a place that we're going to break your circuit and create a switch. So find a place where you have like a good long part, like here or here, and you have to take this tape off carefully, and then we're gonna make a cut and fold back one side. Didn't light anything up, did it?
Wait, actually,
Yeah, it depends on which way you put it, huh?
let's see if it works.
Mama, the dice.
Is the dice an insulator or a
Can
conductor?
someone put it on? Can someone put it on?
Yeah. Ready? Let's test it. Oh, look! He's got the pencil conducting. He's got it touching the graphite.
Is it a pencil?
The pencil is a conductor from what part? What part of the pencil conducts?
Oh,
Your
graphite.
switch only works for the one out here because of the placement of your switch, because your power source is
If
coming from
I
here.
would have placed it like right here,
Then it would have switched them all.
What if
But
we
yeah.
usually-
So Malia's switch works for all of them because her switch is right there. And a paper clip is a conductor. Good job. And which one is that? The nail clippers? What did you predict for the penny? Was it going to be a conductor?
Conductors.
All right, let's see if it conducts. Woohoo! It sure does.
I predicted the penny would be a conductor.
Quick.
Here, where's the thingy majig?
Mine. Oh.
Okay, take this.
Oh, now you're moving different switches around.
Yeah, I made a new.
So that's all a switch is, right? Is a place where when we switch it off, we've broken the current.
We should
What about
make-
the cork? Is it not a conductor, huh? No.
What is this one again?
Eraser.
Eraser. So if I do this, so if I put this here, it acts as a light right here, and it lights above the light, so it acts like one of the
Because it
foil.
conducts between the two
Because
pieces.
it's metal.
My light switch.
Yeah, let's see what your light switch looks
So
like.
I made a light switch, so when it's like that, it's on. But so this is actually a conductor, but look what happens when you connect them. They turn on.
Because your power's over here, where you also have a light, huh?
But they all turn on. And then if you put a conductor there to make a circle, it turns off. On off. It's a little light switch. Kind of like what you'd see in a light. If they connect, it's off. But if they're not connected, then they are on.